Okay, so 69 game two is a pretty easy game to kind of go over grouping and how to make worlds with our groups and stuff like that. So we're going to do 69 game two to go over how to do grouping games. So it's similar to any other game type that we do. So we think about how to eliminate the rule, and we're eliminating the rule by thinking about where our variables can go, placing them down, and the number of spots it could go in. And then it basically, so we don't have to think about it anymore. So that's what we're going to be doing here as we go through the rules. So our prompt says exactly 6 Petri dishes labeled 1 through 6 are to be stored in an otherwise empty refrigerator. So, okay, then it goes on to say there are 3 available shelves, the bottom, the middle, the top, and then the placements must be consistent with the following. So this is a grouping game because it doesn't really matter about like what position they're in within the shelf. It really just matters what level they're in. So we have group bottom, group middle, group top. As a basic diagram, I'm going to do something like this. Usually I do like I go horizontal rather than vertical, but this game in particular is talking about top, middle, bottom. And as I'm going through the questions or even the rules, it's easier to think about it logically if it says like dish 6 is on top of dish 5. If I go vertically, it just makes more sense. So I'm going to go vertically. It doesn't matter which way you do it, so long as it makes sense to you. If you switch it on its side, it's the same thing. So our variables are dish 1, 2, 3, 4, 5, 6. This game's a little different because it's using numbers as the variables. This rarely happens, but I think in this one particular, it's not super difficult to kind of get your mind wrapped around that because we're not talking about placement within the game itself. We're just talking about grouping. So having these different numbers as our variables isn't going to mess us up too much. It's not going to be like the second dish is in the 4th place or something like that. So it'll be a little bit easier for us to like comprehend it. So we're going to go into our rules. First rule says no more than 3 dishes are stored on any shelf. This is a pretty simple rule to kind of just put into our diagram. I should say I drew these 2 lines just because I did. There was no real reason as to why I drew those 2 lines. I think I just stopped talking, or I started talking as I was writing. I just wrote 2 lines. But for this rule in particular, if I know that I can't have more than 3 dishes on my shelf, meaning maximum 3 dishes, I'm going to add an additional line. So that way, if I fill up all my spaces on one of my shelves, I know that I can't add any more because this is my maximum. 3 is my maximum. And this is one of those rules where I wouldn't even write it out as a rule because I can just put it into my diagram like this. So rule 1, completely done. Don't have to worry about that. Rule 2 says dish 2 is stored at least 1 shelf above dish 6. So to write this out, I recommend writing your rules out as the way that you have your diagram set up. So if I know that 2 has to be at least 1 above 6, I'm going to write it something like this, meaning this line can be stretched as far apart as it wants. 2 is always going to be above 6. It doesn't matter how far up it is, but it knows that I know that it has to be on top of 6 in some way. So this is a pretty easy rule to eliminate because if I think about where these variables can go, it actually becomes a little restrictive. So it doesn't really matter which one of those variables we want to touch on. We can do 2 or we can do 6. I'm going to pick on 2 just because it's the first one that I'm seeing. So thinking about where 2 can go, I can either have it at the top or the middle. I can't have it at the bottom because then I don't have room for that 6th one to go into. So because I have 2 options for 2, I'm going to make 2 additional world or 1 additional world. So I have 2 worlds. And I'm going to put 2 on the top and 2 on the middle because those are the only 2 places that my second one can go in. So if I place them there, I don't have to worry about 2 anymore. Now that I've got it placed, it's 1 less variable to think about. And the rest of my rule, I have 6 below 2. So looking at world number 2, it's a pretty easy placement of 6 because it can only go in that bottom shelf. It can't go anywhere else. because 2 has to be above 6. However, in that first world, I have 2 options for 6. So it can either go in the middle or it can go in the bottom. Because I have 2 options where I could put 6, I'm going to break that up into another world. So then I don't have to think about 6 anymore. If I can place my variables and not have to think about them anymore, that's better for me. And it actually helps me eliminate this rule because then it's one less thing for me to think about. So now I've placed variable number 2 and variable number 6, and I don't have to think about the second rule anymore. There's no way that I'm going to eliminate or violate that rule. So I can cross that out in my mind. Ooh, just want to move you up. Okay. So we're going to go on to our third rule, and we're going to do the same thing. We're going to figure out which variable we want to look at, and then look at each of our worlds and place that variable. So rule number 3 is actually really nice because it talks about dish number 6, and we've placed dish number 6. So this will be pretty easy because we know where one of our variables are. So it says 6 is stored either one shelf above or one shelf below. Now, this rule differs from the second rule pretty significantly because that second rule says at least one shelf. This is saying one shelf. So in our second rule, we could have the world where they were split up by 1. But in this second rule, it's saying that there's exactly one shelf. It's not saying at least, or it's not saying at most, it's telling me 1. So for the second rule, if 6 is stored either one shelf above or one shelf below 5, I could write it out something like this. Oop. I can't pull them apart like I have this 2 and 6, and I can't do anything. They can't be on the same level. It has to be 1 or it has to be below. So because I know where my 6 is, this will be pretty easy to implement into my diagram because I'll just have to pop in 5. So if I take a look at world number 3, I know 6 is in that bottom spot. There's only one place that I could put 5. I can't put 5 below it. So 5 has to be above it. So it has to go in that middle spot. Similar or same thing happens to number 2. 6 is in that bottom spot. I can't go below it and I can't go with it. So I just pop 5 right in there. Now, number 1 is a little bit different because 6 is on that middle shelf and I have space on my top and my bottom shelf. So that means 5 could go at the top or 5 could go at the bottom. So because I have 2 different options, I'm going to make that duplicate, that other world. So I don't have to think about 5 anymore. And I'm going to place one where 5 is in the top, one where 5 is in the bottom. Notice that I'm not really caring where I put them within the shelves itself. I care about where it is vertically. So I could, for instance, in the second world, could put 5 over here. Really doesn't matter. Don't care about where they go within the shelves, only caring about the group themselves. So now I've placed rule number 3. I don't have to think about that rule anymore because there's no way I could violate it. My 6 and my 5s are placed. They're rock solid. It's one less variable for me to worry about. So now I've got 3 out of the 6 variables already placed, which is really nice. And I only have one more rule left. My last rule says dish 4 is not stored on the same, or dish 1 is not stored on the same shelf as dish 4. So if I know 1 and 4 hate each other, I can't see them next to each other. So this becomes a little bit flexible because if you'll notice in all of our worlds, we have 6 spots left over. So we have more spots than we have variables, which means that it's going to become a little tricky to write out all these worlds because technically in all of my worlds, I don't have a shelf that's blocked off, meaning that 1 and 4 can pretty much go on any shelf at once, so long as it's not with that other variable. So 1 and 4 just can't be next to one another. So in this case, because I have so many different worlds, because for example, in that first one, 1 can go on the bottom, 4 can switch between top and middle, 1 can go in the middle, 4 can switch between top and middle, 1 can go at top, 4 can switch between top and middle, and it does that for the other 3 worlds. I'm coming up with, I don't even know, I can't do math right now, a lot of worlds. And it's not in our best interest to spend all that time, especially when I only have 3 variables to really worry about. It'll be much easier to just go through the questions and write it in as I need. So I'm going to keep this rule to the side, and I'm just going to kind of think about it when I'm placing 1 and 4 when I go into my questions. Now, my last variable left over is variable number 3. None of our rules talked about variable number 3. 3 isn't forced to go into any place because I have 6 spots left over. So 3 becomes what we call a floater, meaning that it can go anywhere at once and it's not going to violate our game, which is meaning that it's the most flexible variable, which is good for us because it means that if I put 1 and 4 somewhere, I can just throw 3 wherever I want to. It's kind of like a freeze space, I guess you could call it, because nothing happens if I put 3 on the top or 3 on the bottom or stuff like that. Like 3 itself is not going to violate the game. That's the diagram. So as I go through the questions, I'm going to be keeping in mind that 1 and 4 hate each other and 3 is just going to go wherever at once. And if I feel like I need to, I'll write out the diagrams to the side as I go through the questions. But for the majority, or for the general sense of this game, I have a pretty good idea of what's going on in the game. So our questions should be fairly easy. Now, the first question is what we call a list question. It's typically the question on every single, or the first question on every single game. It's just asking you what a possible setup could be. And for those questions, I don't recommend you looking at your diagram. It can take way too long to compare the answer choice to what you have, especially because the answer choice is just going to be one instance, one possible diagram. In this game, because I only have 4 diagrams, pretty much, is not too bad. But once you get to the more challenging games, or game 4, game 5s, it can be a lot. You could have up to 8 worlds, and it's just too time consuming. So for these kinds of questions, I recommend going through the rules and eliminating the answer choices that are violating those rules. So for example, I'm going to look at rule 1. It says that no more than 3 dishes are stored on any shelf. I'm going to go through my answer choices and make sure that I have no more than 3 dishes on each shelf, which eliminates answer choice A, because on that top shelf, I have 4 dishes. So that's wrong. All my other ones are pretty good. I don't have any where I'm exceeding 3, so I can move on to my next rule. My next rule is 2 is stored at least 1 shelf above 6. And so this is one of those games where you have to really pay attention to what is the middle, what is the top shelf, because they're going, or it's in like a sentence structure, I guess you could say. Like they don't have it structured like this, where it's visually easier to see your 2 through 6. So we're just going to make sure that 2 is above 6. So in this B, I have 2 above 6. I can eliminate C because 2 is on that bottom shelf, 6 is on the middle, 2 above 6, 2 above 6. So we're good there. Moving on to our next rule, which says 6 is stored either 1 shelf above or 1 shelf below 5. So I'm going to look at my remaining answer choices and make sure that 6 and 5 are in some way next to one another. So in B, 6 is on the middle, 5 is on the top. We're good there. D, 5 on the bottom, 6 in the middle. We're good there. E is going to be eliminated because 6 is on the bottom and 5 is on the top, which is more than 1 shelf above 6. So we can eliminate that. And my last one is 1 hates 4. So I'm just going to look at the remaining ones, see where I have 1 and 4 together. That would be D. So I'm going to eliminate D. That means that B is our answer choice. If you were to pick that answer, and maybe you didn't feel super confident in it, that is when you could look at your diagrams and compare what you already have. Or if you don't feel confident in your diagrams, you can make sure that you have the correct answer in your diagrams. Because if you've done it the correct way, it should show up in some way. So let's see if we can find answer choice B. Could happen here. We could have 1 3, 6, 2, 5, and 4. So we do have answer choice B in our diagrams, or we could make it happen, I should say. And question 7 says, if dish 6 is the only dish stored on the bottom shelf, which one of the following could be the list of dishes that are stored together on the middle shelf? So first things first, this is giving me an if question, which means it's limiting me to when 6 is only on the bottom shelf by itself. So first thing I'm going to do is figure out which world that's happening in. And that's happening in my pillow pen, third and second world. And if this were to happen, we know that we can't put anyone else down here, which means that 1 and 4, we have to think about 1 and 4 still hating each other. So 1 and 4 are going to flip between here. 3 is going to go on the top here, and 3 is just going to kind of float between top and middle. So now I have an idea of what my diagrams are going to look like. And I have the luxury of having a different color pen. Would not recommend having a different color pen on the test. I don't even know if you can have a different colored pen on the test, but write it out to the side rather than writing directly on your diagram, because you can still use your base diagram for the rest of the questions, and you should still use your base diagram. This doesn't change the diagram for the rest of the game, I should say. So we're looking for something that can be stored. Which one of the following could be the list of dishes that are stored together on the middle shelf? So I'm just looking for the middle shelf, and we're looking for what could be stored together. So that means that in order to choose my answer choice, it has to be the only 2 on that shelf. So if I look at dish A, or answer choice A, 1 and 3, while I could have 1 and 3 on my middle shelf here, it's not my correct answer choice, because in order to have 1 and 3 on that middle shelf, I would have to include 5. So that is wrong. 2 and 4, again, a wrong answer, because I could have 2 and 4 here. I could pick 4 down here and have 2, but in order for it to be my correct answer, it would have to include that 5. So wrong there. Next one, 2 and 3. I can't even have a world where I have 2 and 3 together, let alone by themselves. So that's wrong. 3 and 5. Well, I could have 3 and 5 over here. It would have to include 1 or 4 in that answer choice to be our correct answer choice. So that is wrong. And that leaves me with E, which is 5 or 4 and 5, which I could make happen. I could pick 4 here. I could pick 1 here, and I can put 3 up there, which would just leave me with 5 and 4 on that middle shelf. So that's why E is our correct answer choice. Okay. Next one says, if dish 1 and dish 2 and dish 3 are stored on the same shelf as each other, which one of the following could be true? So again, we're looking for, or it's giving me an if question. It's restricting me to when 1, 2, and 3 are on the same shelf as one another. So I'm going to go through my diagrams before I go through my answer choices and see where I can make that happen. I can only make that happen between 3 and 4, because over here, I can't put 2 with 1 and 3. I don't have the space for it. So up here, I can put 1 and 3 together. 4 is just going to bounce back and forth between the middle and the bottom shelf. So I don't really care where 4 goes. You can write it down there if you want. But now I have a general idea of what's going on in my diagrams. And it's talking about it could be true, which means it just has to happen once in order for our correct answer to be correct. So I just have to find where our answer choice is happening at least once, and that'll be my answer choice. So could it be true that exactly one of the dishes is stored on the top shelf? Well, between my 2 diagrams, that top shelf is always going to be full. So there's no way that I can have 1 or even 2 dishes on that top shelf. It always has to be 3. So this is going to eliminate A, and it actually eliminates B, because it says exactly 2 of the dishes are stored on the top shelf. Again, between these 2 diagrams, I have to have 3. C says exactly 2 of the dishes are stored on the middle shelf. Could I make that happen? I certainly can. I can move that 4 up here and I can have exactly 2 dishes on that middle shelf. So I'm pretty confident that this is going to be our answer. Answer choice D says 3 of the dishes are stored on the middle shelf. I can't have that happen because 4 is my remaining floater. So I could put 4 up on that middle shelf, but I don't have another variable to fill in this spot. So I can't have 3 up there. That makes D wrong. And it also makes E wrong because, again, I could put 4 down here, but I don't have another variable to fill that spot. So I cannot make that happen. So because I can make C happen, that's going to lead me to pick C's because we can make that happen. Number 9 says, if exactly one of the shelves has no dishes stored on it, which one of the following must be true? Ooh, I did not talk about this, but in no way did our scenario indicate or say that all of our shelves have to have at least one dish on it. So technically we could have one shelf completely empty. And that actually can happen in 1 and 2. We can completely forget about top, forget about the bottom. And thinking about my rule over here and my floater variable, I know that 1 and 4 hate each other. 3 is going to fill that empty spot. 1 and 4 hate each other. 3 is going to fill that empty spot. So I have an idea of what's going on in my diagram, which actually between the two, it just shifts down 1, which is kind of funny. So we're looking for something that must be true. And in order for it to have to be true, it has to happen in both of our worlds. Generally, this is a pretty, or these questions can be predicted because if it has to happen in both of the worlds, that means I can look at both the worlds and kind of see what's consistent in both of them. Most of these must be true questions are going to talk about the variables themselves, like 6 has to be in the middle shelf, 2 has to be in the top shelf or something like that. And it's pretty easy to predict. In this case, I don't really have any variables that are in a spot like that have to be in a certain spot in both the worlds. So I don't really have a prediction going into it, which is totally fine. I'm just going to go through my answer choices. Does it have to be true that exactly 3 of the dishes are stored on the bottom shelf? No, it doesn't. Because I can have in this first world, I can have the bottom shelf have nothing. So because it's a must be true, it has to happen in both of them. It not happening in that one world completely makes this answer choice wrong. So I can eliminate A. Exactly 3 of the dishes are stored on the middle shelf. That actually has to be true. And here I'm going to have my variation of 2, 5, and whatever. And up here, I'm going to have my variation of 6, 3, and whatever. So because in both of the worlds, I have to have that middle shelf full, this is going to be my answer choice. But let's go through C, D, and E. Does it have to be true that dish 1 is stored on the same shelf as 5? No. 1 and 4 are going to flip between one another. So even though, or scratch that, I should just say 1 and 4 can flip between one another in both the worlds. So there's no set place that 1 is going to go to. We could have the world where 1 is with 3 and 6 on that middle shelf. Doesn't have to go to with 5. Does it have to be true that 2 is stored on the same shelf as dish 3? That actually can't even happen. In both the worlds, they are on separate shelves. So it doesn't have to be true. It actually has to be false. E, dish 4 is stored on the same shelf as dish 5. Very similar to answer choice C, 1 and 4 are flipping between one another. So 4 could be on the shelf with 6 and 3. So it does not have to be true that 4 is with 5. So our answer choice becomes B. Okay. Question number 10 says, if dish 5 is the only dish stored on the bottom shelf, and if exactly 2 of the dishes are stored on the middle shelf, which one of the following is a pair of dishes that must be among the dishes stored on the top shelf? This is a very wordy question, but we can split up these parts. This question into parts, and we can just focus on it chunk by chunk. So the first part that I'm looking at is if dish 5 is the only dish stored on the bottom shelf. I'm going to look for where that happens so I can narrow in my diagrams. So that actually only can happen in this 4th world. 5 can be a loner down here. But we have the other caveat of exactly 2 dishes. 2 of the dishes are stored on the middle shelf. So that means that I don't have a third dish here. I can only have these 2, which if we think about what variables we have left over, 1 and 4 hate each other, which means that it's going to either be 1 or 4 on that middle shelf, and 3 is just going to pop in on that empty spot. Then the rest of the question says, which one of the following is a pair of dishes that must be among the dishes stored on the top shelf? So this is one of those questions where we could predict it because it's talking about the dishes themselves, and it's a must be true, which means it has to be concrete, has to happen all the time. So if we're looking at the top shelf for this question, I'm looking for the variables that are set in stone. I'm not going to move around. So my prediction right off the bat is 2 and 3. 2 and 3 have to go at that top shelf. 1 and 4 are going to flip between one another. So I could have 1 up there. I could have 4 up there. So because 2 and 3 are always going to be at the top, and that's what the question's asking me, that's my prediction. And that actually is answer choice C. And I don't have to do anything else because that's my answer choice. All the other ones don't have to be true, which is why I love must be true questions, because they're fairly easy to predict. Okay, next one says, if exactly one of the dishes is stored on the middle shelf, which one of the following could be the list of dishes stored on the top shelf? Okay, so it's giving me another if question, which means that we're going to go through our diagrams and make sure that we have worlds where we can have exactly 1 on that middle shelf, which only happen on world number 1, 3, and 4. This one just it doesn't happen. So if we have exactly one of the dishes on the middle shelf, that means no one can go here, here, and here. And if I think about my rule of 1 hates 4, that means that it's going to flip between here, the top, and the bottom in both those worlds. And in 4, 3 is just going to be a floater between the top and the bottom. And 3 is going to be on the top and the bottom. But in 1, we know that 3 is going to have to go on that bottom shelf. There's no other space for it to go anywhere else. So now we're looking for which one of the following could be the list of dishes stored on the top shelf. Okay, so again, this is very similar to that other question. I can't remember which one it is, but in order for us to pick our answer choice, it has to be those only 2. So all of our answer choices are containing 2 dishes. It has to be those 2 and no one else. So for example, if I look at world number 1, or actually, let me see if it's in here. Yeah, we can just go into answer choice A. But no, how do I want to do this? Where am I seeing a wrong answer? I'll go down to D. Let's go down to D. So looking at D, I could have 3 and 4 on that top shelf. I can make that happen here and here. We could put 3 in there, and we could put 4. We could pick 4 here, but in order for us to be able to pick D, it would have to include dish number 2. So it's the full and comprehensive selection of the dishes that we're picking from. And the way we can figure that out is it's saying could be the list of dishes. So it's talking about a comprehensive list. So that eliminates D. Let's go back up to answer choice A now that I've explained it. Answer choice A is dish 1 and 2. Can I make that happen? I can make that happen right here. I can put 1 and 2 up at the top shelf, and I can move 3 down here and have that be the only 2 up there. So I like A. I'm nervous about A because it's the first answer choice, and I always get nervous when it's A or E. So I'm going to go through B, C, and E and just make sure that it's A. But I'm feeling pretty confident about A. 1 and 5, can I make that happen? Well, I could have 1 and 5 up here, but again, because we're looking at a comprehensive list, in order for us to pick B, 2 would have to be somewhere else. So in order for us to look at 1 and 5, it would have to include 2. So B is wrong. I don't know why I did that. There we go. C, just 2 and 3. I can make that happen in both those worlds. I can put 3 here, but again, in order for us to pick answer choice C, we would have to include either 1 or 4 along with that answer choice. So I can't have 2 and 3 by themselves. So that makes that wrong. And 3 and 5, there's no world in either of these where I could have 3 and 5 together on the top shelf, or yeah, I could have 3 and 5 on the bottom, but like on the top shelf, can't have 3 and 5 anywhere. So that's just a must be false. So our answer choice is A. Use my eraser. I don't think the nerves on picking answer choice A or E ever really go away. I always get a little nervous picking them, but once you go through the answer choices, you feel a lot better, especially because it takes you all of like 5 seconds to do so. And that's our last question. So hopefully this clarifies this game, or how to use your diagram, how to build your diagram for grouping games. This is a pretty good basic grouping game to kind of start learning from. So I would recommend doing this game again until you kind of feel comfortable with it, because from here on, the games usually get pretty difficult. This is, I would say, like a level 1, level 2 grouping game. And if you're not comfortable with that, you're not going to be comfortable for the other games. So let me know if you have any questions. I'm always free, but yeah, hopefully this helped. Thanks.